Exponential functions. Exponential functions have the form of a constant times a base raised to the x power. Our base here is always going to be a positive number. And for these examples, our constant will also be a positive number. Exponential functions have a lot of uses in population growth, in bacteria growth, in decay problems like radioactive decay, in compounded interest. So there's a lot of many different types of applications that use exponential functions. We have the graphs that really are going to have two basic shapes. When you have a function that is an example of a growth function, exponential growth, your negative x values down here are going to get real close to that x-axis, almost lying right on top of it. Your y's get so close to 0 here. They stay positive, but they get real close to 0, so that gets very flat. And then it's increasing at the other end of the graph. In exponential decay, it's just kind of flip-flopped. The first tail is the tail that goes up. Here, we're going way up as our x's get negative. But as our x's go out the positive x-axis and get bigger, our y values get real close to 0. So this part of the graph looks like it's lying almost directly on top of that x-axis. So let's graph a function. In order to graph these functions, what we really want to do is get the table of values here. So let me pull my calculator over. Make it bigger so we can see it. And I want to put my function into my y equals screen. So I go to y equals, and I clear whatever's in there. And then I just type 3 raised to the x power. What I want to do is get some ordered pairs so I can plot these points on my graph. Now, I use my up and down arrows to scroll through my x, y table. I notice that as I use negative x's, notice how those y values are getting so small. Here it even bumps it into scientific notation because there's so many zeros here behind the decimal point. So what I want to do is graph a few negative values and a few positive, a few negative x's and a few positive x's. So let me try to graph here negative 3. If x is negative 3, negative 1, negative 2, negative 3, my y value is 0.037. So that's very, very, very tiny. That's just right there, barely above that x-axis. Negative 2 has a y value that's still just barely above it. It's a little bit higher than this one, but it's just barely above that x-axis. Negative 1 is about at 1/3, so I can come up a little bit higher for that one. 0, 1, 1, 3, then I can do 2, 9, and that's probably all I can go out, because if I get a bigger number, 27, that's going to really be too big to fit on most of your grids. So I get my basic shape here. Again, your graph can look a little bit better than mine. It's hard to graph on this program that I'm using. But there's the basic shape of the graph. You want it to look like a smooth curve. So this is an example of exponential growth. This function for my a here, the base, is between 0 and 1, is going to be an example of exponential decay. So let's graph it using the same ideas, putting the function in our y equals screen. You do need to be careful here. Be sure you put the 2/5 in parentheses, because we want the entire fraction raised to the x power. Now let me get some ordered pairs. Now here, notice that my negative x values have larger y values. Here, negative 3 has a y value of 15.6, so a little bit larger than 15.5. So let me graph that. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.5. So it's going to be around right there. I hope I counted those right. Now negative 2 is at positive 6, and a little bit more, a quarter, 0.25, 6.25. Negative 1 is at 2.5. Then I have the 0, 1. Then 1 is 0.4 for the y value. So it's down here. Then 2 is 0.16. So notice again, these are getting very close to that x-axis. So then I can connect these, try to make it a smooth curve. And make this tail go out almost flat. And there is my function that is an example of exponential decay.